For more than a century, archaeology has relied on a simple, comfortable story. Early humans were primitive, slow to change, and incapable of building anything complex until long after the Ice Age ended. But a wave of discoveries from the last decade, especially within the last 2 years, has torn open that narrative. The turning point came from a place already known for rewriting history, Göbekli Tepe. 12,000 years old and mysteriously buried by its own builders, Göbekli Tepe has always challenged scientific assumptions. But the real shock struck in October 2025, when archaeologists announced the discovery of 50 new T-shaped pillars hidden beneath layers once believed to be fully excavated. These pillars are enormous, carved with a mastery that should not exist in a world still labeled Stone Age. Some weigh more than 10 tons. Many contain intricate animal reliefs cut with precision that suggests knowledge of tools, techniques, and planning far beyond what traditional models allow. And Göbekli Tepe is only the first of 6 mysteries now forcing scientists to look again at humanity's forgotten past. A second revelation emerges from Karahantepe, where an 11,000-year-old human face carved into bedrock displays proportional accuracy and emotion that modern sculptors struggled to achieve. In the jungles of Guatemala, high-resolution LiDAR revealed a 3,000-year-old Mayan city in November 2025, vast, interconnected, and completely unknown to history. Its size instantly pushes the timeline of Mesoamerican civilization backward. In Peru, the enigmatic band of holes stretches across the Nazca Desert, more than 6,000 circular pits carved in patterns that still defy explanation after 60 years of study. Meanwhile, in Australia, signs of a 40,000-year-old stoneworking tradition at Boscombe reveal techniques that look shockingly advanced. And, woven through all of these discoveries is the 6th mystery: standardized ancient measurements and writing systems appearing across distant continents. Each site raises questions on its own. Together, they form a pattern hinting that early humans may have been more organized, more knowledgeable, and more capable than modern science ever expected. The central conflict begins with this uncomfortable truth. The evidence no longer aligns with the textbooks. According to the established timeline, people living 12,000 years ago were nomadic hunter-gatherers with no agriculture, no permanent settlements, and no complex social structure. Yet, the builders of Göbekli Tepe clearly coordinated hundreds of workers, transported megaliths, carved sophisticated symbols, and aligned structures to celestial events. None of this fits the traditional model. The problem is not just the age of the site, it's the sophistication, precision stonework, astronomical alignment, large-scale organization, symbolic language, all emerging thousands of years too early. And similar patterns appear across the planet. How can a 40,000-year-old Australian site show advanced stone processing? How can the band of holes demonstrate systematic planning without any nearby settlements? How can a Mayan city of massive scale exist centuries before current textbooks suggest the civilization even began? These discoveries do not support slow, gradual development. They suggest sudden leaps, bursts of knowledge and organization that cannot be easily explained. And this is what leaves scientists uneasy. The basic framework of archaeology was built on the belief that civilization evolves in a straight line, simple societies first, complexity later. But again and again, The evidence contradicts this. Instead of a steady climb, the past now appears punctuated by moments of rapid advancement, moments that seem to come from nowhere. This forces a deeper question. Did early humans possess knowledge that later generations lost? If so, how widespread was that knowledge? And why do traces of it appear in regions separated by oceans? Experts disagree. Some argue the finds are isolated anomalies. Others insist they must be reinterpreted within existing theories. But with every new excavation and every new LiDAR scan, the anomalies multiply. The discoveries do not cluster around one culture or one region. They span continents, climates, and time periods. The tension grows because the evidence is physical. You can touch the pillars. You can measure the stone cuts. You can map the cities and analyze the alignments. These are not myths or legends. They are structures built with intention and intelligence. And they quietly challenge the assumptions that have shaped modern understanding for generations. There is also a new question emerging, one that scientists rarely ask publicly. Why are these discoveries appearing now? Is it simply better technology? Coincidence? Or are we uncovering pieces of a much larger story, one that stretches back far earlier than we ever imagined, waiting beneath soil, jungle, and desert? Whatever the answer, the pattern is undeniable. Humanity's past is no longer a straight line. It is a mosaic, fragmented, surprising, and far older than anyone expected. And to understand that mosaic, we must return to the place where the first cracks appeared, where ancient builders left messages in stone long before written language existed, and where the timeline of civilization began to unravel. For decades, archaeology depended on a simple model. Early humans advanced slowly, building knowledge layer by layer. Every new discovery was expected to fit into that structure. But the growing list of ancient anomalies, Göbekli Tepe, Karahantepe, the hidden Mayan city, the Band of Holes, the Australian stoneworks, and unexplained writing systems, has pushed this model to its breaking point. Science is confused because the evidence no longer fits the story it has defended for generations. Much of this confusion comes from decades of failed explanations. When Göbekli Tepe first emerged, scholars insisted it had to be a ritual site because acknowledging a highly organized society at 12,000 years ago challenged everything they believed. Karahantepe's precisely carved 11,000-year-old human face was initially dismissed as symbolic art, even though its technical skill is undeniable. When LiDAR revealed an enormous Mayan city under Guatemala's jungle, some experts argued that the readings were exaggerated until the structures were verified. Again and again, new discoveries meet resistance long before they are accepted. This resistance exists because modern archaeology is built on stability. Careers, textbooks, and long-standing theories rely on the idea that civilization developed slowly and predictably. When a discovery undermines that structure, the instinct is to reinterpret the evidence rather than revise the entire timeline. But the anomalies are now too numerous to ignore. One site can be overlooked. 6 across different continents cannot. Older hypotheses are collapsing quietly. The belief that agriculture must come before monumental architecture was overturned by Göbekli Tepe. The idea that writing appears only in advanced societies is contradicted by structured, unresolved scripts in Southeast Asia. The assumption that ancient cities grow gradually over centuries fell apart when Guatemala's LiDAR maps revealed large-scale urban planning far earlier than expected. And the notion that early humans lacked advanced stoneworking tools cannot survive against 40,000-year-old engineered cuts in Australia. These failures don't just challenge individual theories, they undermine the entire staircase model of human progress. If agriculture didn't appear first, if writing didn't appear last, if cities can emerge suddenly, and if stone technology was mastered long before expected, then the timeline itself must be reconsidered. Instead of a steady climb, the past begins to look like a landscape of rapid advancements, forgotten knowledge, and civilizations that rose and vanished without leaving clear descendants. This leads to a deeper, more uncomfortable idea. Modern science may be seeing only fragments of a much older, larger system of knowledge. If ancient societies reached peaks of organization and technology that were later lost, then history is not linear. It is cyclical. This possibility challenges both academic tradition and cultural belief because it suggests our ancestors may have known things we no longer understand. The confusion intensifies because these findings contradict each other's expected timelines. Göbekli Tepe is too early. The Mayan city is too early. The Band of Holes is too engineered. The Australian stone cuts are too ancient. And the writing systems appear where writing should not exist. Together, they force the question that archaeology has avoided. How did early humans accomplish so much so early? Explanations like coincidence or isolated invention no longer seem adequate. Similarities in measurements, symbols, and architectural solutions appear across regions separated by vast oceans and tens of thousands of years. These may not prove direct connection, but they strongly challenge the assumption that early humans were isolated or primitive. As more evidence emerges, the scientific world is slowly shifting. Younger researchers are re-examining assumptions. Funding is moving toward sites once ignored. The confusion itself signals a turning point, the moment before an outdated model finally gives way to a broader view of human origins. But the most significant change is happening outside academic walls. For the first time, the public can see LiDAR scans, excavation footage, and artifact reconstructions without waiting for institutions to filter them. When people see a 12,000-year-old megalith or a 40,000-year-old engineered stone cut, they don't see an exception. They see proof that our story is larger than the version printed in textbooks. These discoveries don't weaken science, they expand it. They force researchers to reconsider old assumptions and confront new possibilities. Did ancient humans inherit forgotten knowledge? Did they develop technologies now lost? And how much of their world vanished long before we began recording history? One thing is certain. The clues rising from soil, desert, and jungle suggest that humanity's past is deeper and stranger than we ever imagined, waiting to be rediscovered piece by piece. Long before the rise of cities, long before writing or agriculture appeared in the historical record, a group of ancient builders carved their vision into limestone on a hill in southeastern Turkey. Göbekli Tepe has always stood as an archaeological contradiction, too old, too advanced, and too well planned for the world it came from. But everything changed again in October 2025 when researchers uncovered 50 additional T-shaped pillars hidden beneath layers earlier excavations had never reached. Suddenly, the site once thought to be partially explored expanded into something far larger than anyone imagined. The story began in the 1990s when a shepherd noticed carved stones jutting from the soil. Early excavations revealed monolithic pillars arranged in circles, many decorated with animal reliefs carved with surprising accuracy. At 12,000 years old, Göbekli Tepe predates the pyramids by millennia. According to traditional models, The people of that time were nomadic bands without permanent settlements or organized labor. Yet these pillars weigh several tons, were shaped at quarries miles away, and required careful engineering to stand upright. The scale alone challenges everything we thought we knew about early humans. For years, scientists tried to fit the site into familiar explanations, calling it a ritual center, a symbolic structure, or a ceremonial gathering place. But the new discovery from 2025 shattered those comfortable interpretations. Some of the newly detected pillars are larger than any previously uncovered. Others display unfamiliar motifs and stone surfaces smoothed with a level of precision that seems incompatible with simple tools. The newly mapped enclosures suggest the site may have been part of a vast complex, possibly with astronomical or calendrical functions. These findings raise a difficult question. How did a supposedly primitive society organize hundreds of workers to shape, transport, and raise massive limestone pillars? The old assumption that early humans lacked social structure no longer holds. The layout of the deeper enclosures indicates geometric planning. Some patterns appear intentionally aligned with sky events, and the oldest levels show more refined craftsmanship than later ones, suggesting that knowledge declined over time instead of evolving gradually. One of Göbekli Tepe's most mysterious features is its deliberate burial. The entire complex was covered with thousands of tons of stone and soil, as if intentionally sealed. This was not the work of natural erosion. It was organized labor on an enormous scale. Why would a society bury the most sophisticated structure it ever built? Was it a ritual closure, a response to crisis, or a transition to a new era of belief? The new pillars reveal even deeper layers of burial, suggesting long-term systematic effort. What makes the site even stranger is the absence of anything we would expect to find around such a monumental construction. No homes, no tools, no clear signs of permanent settlement. It is as if the builders arrived, constructed an extraordinary architectural complex, and then disappeared without leaving a trace of their daily lives. Comparisons to other ancient sites only deepen the puzzle. Stonehenge, built thousands of years later, is less complex in design and craftsmanship. Other sacred sites around the world share hints of similarity. Large stones, symbolic carvings, astronomical alignments. But none match Göbekli Tepe's age or sophistication. Its existence implies that advanced architectural ideas emerged far earlier than modern science ever anticipated. The 2025 discovery forces archaeologists to face a hard choice: accept that the timeline of human development is incomplete, or dismiss a growing body of physical evidence. Some researchers now propose that early humans developed bursts of innovation that later disappeared. Others suggest shared cultural traditions once spread across regions long before recorded history. A few consider the possibility that Göbekli Tepe represents not the beginning of civilization, but the remnant of something older. Whether the site functioned as an ancient observatory, a ceremonial center, or a place of gathering and knowledge, one truth is undeniable. The new pillars reveal that Göbekli Tepe was part of a much larger and more intricate world than anyone expected. A world where early humans possessed skills, organization, and symbolic understanding far beyond the limits assigned to them. And with deeper layers still untouched beneath the hill, the most important discoveries may not yet have been uncovered. The more archaeologists study Göbekli Tepe, the clearer it becomes that the site does not fit anywhere within the established story of human history. Its age alone contradicts the belief that complex societies only emerge after agriculture. But the deeper researchers look, the more they uncover details that dismantle long-standing assumptions about how civilizations form, how knowledge spreads, and how early humans understood their world. One of the greatest challenges is the absence of any nearby settlements. Sites with monumental structures, pyramids, temples, ceremonial plazas, always come with layers of surrounding life. Houses, workshops, food waste, tools, cemeteries. But around Göbekli Tepe there is nothing. No village, no farms, no signs of long-term habitation. This emptiness forces scientists to consider a possibility rarely entertained in archaeology, that early humans may have gathered seasonally or regionally to build something extraordinary without living permanently beside it. Such organization would require communication networks, leadership, shared beliefs, and planning far beyond what the timeline allows. The site also challenges assumptions about technological development. Traditional models claim that stoneworking evolves gradually, moving from simple tools to more complex techniques over thousands of years. But the oldest layers at Göbekli Tepe show the most refined craftsmanship. The deeper the excavation, the finer the carving. This reverse progression suggests the builders began with advanced knowledge that slowly faded, an uncomfortable idea for archaeology, which prefers linear advancement over decline. Even more puzzling is the engineering itself. Raising limestone pillars that weigh several tons requires precise coordination. The stones must be quarried, shaped, transported, and set upright at the correct angle. In modern engineering, such tasks require calculations, planning, and specialized labor. How did small bands of hunter-gatherers accomplish this without domesticated animals, wheels, or metal tools? No archaeological theory currently explains such organization, and every new pillar uncovered in 2025 adds to this challenge rather than resolving it. Comparisons with later ancient sites highlight the magnitude of the puzzle. Stonehenge, built 6,000 years later, uses smaller stones and simpler arrangements. Monuments across Egypt, Mesopotamia, and the Americas reflect societies with agriculture, writing, mathematics, and centralized leadership. Göbekli Tepe predates all of them, yet its symbolic carvings, architectural planning, and monumental scale suggest a cultural sophistication that later civilizations built upon, not invented. Scientists have long assumed that agriculture created the conditions necessary for large-scale construction. The logic is simple. Farming produces food surpluses. Food surpluses support larger populations. Larger populations build monumental architecture. But Göbekli Tepe flips this sequence. Here, monumental architecture appears first. Agriculture appears later. This reversal implies that religion, shared belief, or knowledge systems may have played a far bigger role in early human organization than previously acknowledged. Another anomaly is the symbolic language carved into the pillars. The animal figures, serpents, foxes, cranes, lions, are arranged with deliberate symmetry, as if communicating rituals or cosmological ideas. Some researchers have proposed that the carvings encode myths, seasonal patterns, or astronomical knowledge. Others argue they represent territorial symbols or clan identities. Whatever their meaning, the carvings demonstrate a capacity for abstraction and communication thousands of years earlier than any accepted writing system. The site's astronomical features deepen the mystery. Early studies suggested that certain enclosures align with solstices or star paths. Now, with more pillars detected in 2025, researchers are seeing patterns that resemble early observatories, circular layouts tracking lunar cycles or seasonal shifts. For such alignments to be intentional, the builders needed long-term sky observation and the ability to record these observations across generations. This challenges the belief that astronomy began with Bronze Age civilizations. Perhaps
The most haunting puzzle is the intentional burial of the site. Covering Göbekli Tepe required moving thousands of tons of material. This was not abandonment, but a massive, coordinated effort. Why bury a sacred center that took generations to build? Was it an act of protection, a ritual closure, or a response to climate or social upheaval? No known hunter-gatherer group has ever buried an entire monumental complex. The action suggests symbolic thinking at a scale rarely associated with the ancient world. All these contradictions leave archaeology in a difficult position. The evidence forces experts to ask questions they once avoided. Did early humans possess forgotten knowledge? Were there regional networks of shared ideas long before the first recorded civilizations? And if Göbekli Tepe was only one of many such centers, how many more lie hidden beneath soil and time? The 2025 discoveries hint at a larger pattern. Göbekli Tepe may not be a singular miracle. It may be part of a broader, older cultural system stretching across prehistoric Anatolia. Karahantepe, Nivali Chori, and several newly identified sites share similar pillars, motifs, and architectural styles. Together, they suggest an early world where knowledge traveled, communities gathered, and monumental architecture served as a unifying force. Whatever the true purpose of Göbekli Tepe, one fact remains clear. The site breaks nearly every assumption about early humanity. It forces modern science to confront the possibility that civilization is older, more complex, and far less linear than we ever imagined. And with more of the hill still waiting to be excavated, the next discovery may challenge our understanding even further. In southeastern Turkey, only a short distance from Göbekli Tepe, another ancient site has begun drawing the attention of archaeologists around the world. Karahantepe may not be as famous, but its discoveries are equally disruptive, perhaps even more so. If Göbekli Tepe challenges the timeline of architecture, Karahantepe challenges the timeline of human artistic and symbolic expression. And at the center of that challenge is a single image, an 11,000-year-old human face carved directly into bedrock with a level of realism that defies the period it belongs to. The face was uncovered during excavations that began in the late 2010s, but only in the last few years have researchers understood its implications. Unlike the abstract figures at Göbekli Tepe, this carving displays clear anatomical detail, defined cheekbones, curved lips, a precise jawline, and deep-set eyes shaped with deliberate depth. The expression appears intentional, somewhere between calm and solemn, suggesting emotional awareness and mastery over stone that no hunter-gatherer society is expected to have possessed. What unsettles researchers most is the technique. The carving shows controlled tool marks, uniform depth, and smooth surfaces in areas that demand advanced workmanship. Modern sculptors have remarked that replicating such form in limestone requires planning, symmetry, and an understanding of human proportion. Yet Karahantepe predates metal tools, wheel technology, and written records by thousands of years. According to traditional archaeology, this level of artistic realism should not appear until much later civilizations like Mesopotamia or Egypt. But here it is, older, sharper, and more deliberate. This discovery does not stand alone. Near the carved face, excavators found a network of carved chambers, benches, and stone installations resembling ritual or communal spaces. Many feature circular layouts similar to certain structures at Göbekli Tepe, suggesting the two sites may have belonged to the same cultural sphere. The layouts display intentional design, with pathways, openings, and carved platforms that imply structured gatherings or ceremonies.
Such organization demands social coordination and shared belief systems, traits long assumed to emerge only after agriculture took root. But Karahantepe predates farming. Its people, according to the conventional timeline, should have been simple foragers focused on survival. Instead, they created a landscape of symbolic spaces and human imagery. The contrast between expectation and reality grows sharper with every excavation. The carved face also carries an emotional weight rarely seen in prehistoric art. Rather than a stylized mask or mythical figure, it feels human, recognizable across cultures and time. It suggests the creators understood not just how to carve stone, but how to convey identity, presence, and perhaps even narrative meaning. This level of expression raises profound questions. What stories were they telling? Who were they depicting? And how could a world without cities produce art that feels so intentional? Connections between Karahantepe and Göbekli Tepe deepen the mystery. Both sites feature T-shaped pillars, circular enclosures, and animal motifs. Both show signs of shared symbolic language. Both appear to have served functions beyond simple survival, likely spiritual, cosmological, or social. And both sites contradict the belief that complex cultural expression emerges only after economic stability. Here, symbolic culture seems to come first. One of the most striking features of Karahantepe is the presence of seated human figures carved into stone benches, figures with distinct posture, anatomy, and presence. They appear as part of a coordinated design, not random decoration. These sculptures indicate that the community possessed not just artistic ability, but a structured worldview, one that valued representation of the human form long before most known civilizations dared to depict it so boldly. The context surrounding the carved face adds further layers. The chamber in which it was found includes a carved channel system, possibly used for liquid, water, or ritual substances. Some researchers believe the space may have been used for ceremonial practices involving movement or flow. Combined with the human face, the architecture suggests a fusion of symbolism, engineering, and ritual behavior that challenges every assumption about Mesolithic societies. Even more surprising is that Karahantepe, like Göbekli Tepe, shows no sign of long-term domestic life. No permanent homes, no agricultural fields, no evidence of sustained habitation. This pattern suggests that people traveled to these sites purposefully, gathering for reasons deeper than survival. They carved, built, and shaped stone with intention and then left. Such behavior implies regional networks, shared identities, and organized gatherings, far earlier than conventional anthropology allows. This raises a broader question. If early humans in this region possessed such abilities, were similar cultural expressions developing elsewhere? The carved face of Karahantepe may be a surviving clue from a much larger world, a network of early symbolic traditions now buried beneath time. The face itself remains a riddle. It may represent a leader, a deity, an ancestor, or an idea embodied in human form. But whatever its identity, it reflects a level of mastery that forces archaeologists to confront a surprising truth. Symbolic thinking, artistic realism, and complex ritual behavior appeared not at the dawn of early civilization, but thousands of years before civilization officially began. And like Göbekli Tepe, Karahantepe offers only a glimpse of what may still lie hidden beneath the earth, waiting to challenge our assumptions even more. The discoveries at Karahantepe force modern science to confront a paradox. How can a society capable of producing realistic sculpture, coordinated architecture, and symbolic spaces leave behind no settlement, no tools, no written records, and no clear trace of daily life?
Archaeologists expect advanced creative expression to emerge alongside agriculture, permanent housing, and growing populations. But here, the art appears without the civilization that should have produced it. Karahantepe's silence is as revealing as its carvings. The absence of traditional evidence raises an uncomfortable possibility. We may be looking at a sophisticated cultural system that left almost nothing behind. The inhabitants appear to have carved stone, conducted rituals, and gathered for symbolic purposes, but not lived on site. This pattern mirrors Göbekli Tepe, where monumental complexity exists without supporting infrastructure. Two sites with the same contradiction cannot be coincidence. Instead, they suggest a broader prehistoric tradition, one that flourished not through cities, agriculture, or written systems, but through mobile networks of communities who carried knowledge across landscapes. The craftsmanship at Karahantepe hints at this hidden world. The seated human figures carved into stone benches are more than artistic decoration. They imply roles, status, and narrative meaning. The carved channels suggest controlled rituals. The central face carved into bedrock demonstrates an understanding of identity and human representation long before such concepts appear in accepted history. These elements point to a society capable of abstract thinking, coordinated effort, and shared symbolic language. The biggest question is how such a society acquired and passed down its knowledge. Without writing, knowledge usually fades within a few generations. Yet the consistent style, repeated motifs, and architectural patterns found across sites in the region indicate continuity. Either oral traditions were far more sophisticated than assumed, or these communities maintained an organized method of preserving techniques and beliefs. Both scenarios challenge the idea that early humans lacked stable cultural memory. What troubles researchers most is the level of precision in the stonework. Smooth surfaces, accurate symmetry, and carefully shaped contours suggest advanced technique, not random carving. Some stones show evidence of controlled pecking, smoothing, and polishing. These methods require time, practice, and teaching. This implies that Karahantepe was not a spontaneous creation, but the product of skilled individuals within a structured community. Yet archaeologists have not found workshops, tools, or living quarters. It's as if the builders vanished between visits, leaving behind only their ceremonial footprints. The mystery deepens when comparing motifs from Karahantepe with those from Göbekli Tepe. The T-shaped pillars, animal symbols, and circular enclosures appear in both places, alongside similar artistic impulses. This shared language suggests that multiple sites were part of a coordinated cultural network. Instead of a single, lost settlement, the region may once have hosted a dispersed civilization, one that moved across the landscape, gathering at communal centers for reasons we can only imagine. Some archaeologists propose that these sites were early temples where different groups met to share rituals, reaffirm alliances, or exchange knowledge. If true, this would shift the origin of civilization away from agriculture and economics and toward belief systems and symbolic expression. In this model, spirituality, not farming, may have been the first force strong enough to unite people at a large scale. Others argue that the artistic and architectural advancements at Karahantepe and Göbekli Tepe may represent the remnants of an older, forgotten tradition that predated even these sites. The abrupt appearance of skill, followed by slow decline, echoes patterns seen in other ancient cultures where knowledge faded after periods of intense innovation. If early humans once possessed a broader knowledge system, mathematical, artistic, or cosmological,
Its disappearance could explain why later civilizations appear to reinvent ideas that may have existed thousands of years earlier. Another clue lies beneath the surface of the region. Recent surveys have identified several yet unexcavated mounds across southeastern Turkey that share geological signatures with known prehistoric sites. If these mounds contain similar pillars, carvings, or architectural layouts, they could reveal a cluster of interconnected ceremonial centers spanning hundreds of square miles. Such a discovery would shake the foundations of world archaeology, implying that advanced symbolic culture was widespread long before cities emerged. Karahantepe's most important contribution to this unfolding story is how deeply it humanizes the prehistoric world. The carved face does not belong to mythology. It looks like a memory, a portrait of someone who mattered. The seated figures reflect social identity. The chambers reflect organized purpose. These elements show that early humans understood themselves and their world in ways far richer than the archaeological timeline allows. Yet, they left almost nothing behind. No written tablets, no villages, no burials that reveal hierarchy. Only stone, clean, intentional, silent. This silence is not ignorance. It is absence. And absence suggests a world that operated differently from the civilizations that came after. A world where knowledge moved through people, not institutions, and where identity was carved into stone, but not tied to permanent settlements. Karahantepe reveals a civilization without cities, a culture without agriculture, an artistic tradition without recorded language, yet undeniably complex. It forces us to reconsider what civilization truly means. Is it cities and walls, or shared symbolism and memory? Is it agriculture and writing, or the capacity to plan, carve, align, and express? Whatever.
The answer, one thing is clear. The builders of Karahantepe belonged to a society far more advanced than the term hunter-gatherer can describe. And their legacy, preserved in stone, hints at a chapter of human history that we have only begun to uncover. In November 2025, deep in the dense jungles of northern Guatemala, a LiDAR scan revealed something so vast and unexpected that it instantly sent shockwaves through the archaeological community. Beneath layers of vegetation, hidden for nearly 3,000 years, lay the remains of an enormous Mayan city, one that had never been recorded, excavated, or even suspected. Overnight, the discovery forced historians to rethink not just the origins of Mayan civilization, but the entire timeline of urban development in Central America. The city stretches across miles of jungle, with plazas, elevated roads, defensive walls, reservoirs, towers, and structures that indicate complex planning. Unlike smaller settlements discovered in the past, this metropolis shows clear evidence of urban organization, grid-like layouts, connected causeways, and multi-level platforms. The level of coordination required to build such a city demands advanced leadership, engineering skill, and social structure. Yet according to current models, the Maya were not supposed to possess such capabilities at this early date. What makes the discovery even more startling is that the city predates the widely accepted origins of Mesoamerican urban development by centuries. Traditional textbooks place the rise of major Mayan cities around 500 to 400 BCE, but the architecture mapped in 2025 suggests construction began far earlier, possibly as early as 1000 BCE. This means the Maya were building monumental structures and managing complex societies long before scholars believed possible. The LiDAR data shows not just isolated buildings, but an integrated system. Roads linking distant areas, water management structures designed for both dry and rainy seasons, and defensive features implying political tension or organized conflict. The scale of engineering raises an immediate question. How could a civilization considered emerging at the time achieve such technical proficiency? Archaeologists have long known that the Maya were master planners, but this discovery demonstrates that their sophistication appeared abruptly. There is no gradual progression, no slow build from small villages to large cities. Instead, the city uncovered in 2025 suggests a leap in development, a sudden emergence of architecture, governance, and engineering that challenges linear models of cultural evolution. The architecture itself offers clues. Many structures follow standardized patterns seen in later classical Mayan sites: stepped platforms, ball courts, ceremonial plazas, and central pyramidal forms. This suggests that many cultural traits considered late were actually present much earlier, hinting at a deeper origin of Mayan identity. The presence of sophisticated water reservoirs, engineered to capture, store, and distribute water, reveals that the Maya understood environmental management far earlier than expected. Such infrastructure would have required planners who could predict climate patterns and coordinate large groups of workers. Equally mysterious is the city's artistic expression. Although much remains to be excavated, LiDAR hints at sculptural forms and stelae, stone monuments that often contain symbolic carvings or early writing. If inscriptions are found, they may push the timeline of Mayan literacy back by centuries, reshaping our understanding of when complex communication systems developed in the region. Another aspect confounding researchers is the city's strategic placement. Built atop naturally elevated terrain, the location offers both defensive advantage and broad visibility, suggesting long-term planning and awareness of geopolitical dynamics. Such placement implies that the Maya were already engaged in regional networks, possibly trade, alliance building, or conflict, far earlier than predicted. But the greatest mystery is why the city remained unknown. Unlike cities lost in myth or buried deep underground, this metropolis was simply swallowed by jungle. Over centuries, vines, roots, and earth reclaimed every stone until nothing visible remained. Only LiDAR's laser mapping, capable of scanning through vegetation, was able to reveal its true shape. The fact that such a massive urban center could disappear entirely raises a profound question. How many more ancient cities lie hidden beneath the canopy, waiting to rewrite history? The discovery also forces scholars to revisit assumptions about population density. The city's size implies tens of thousands of inhabitants, families, laborers, artisans, leaders, and priests. To support such populations, there must have been extensive agricultural systems surrounding the city. Terracing, irrigation, and field networks likely fed its citizens. This means the Maya mastered large-scale food production earlier than previously believed. Agriculture, architecture, governance, and religion may have co-evolved in ways not captured by current timelines. Most striking of all, the city appears not as a beginning but as part of an already mature cultural system. The complexity of its layout suggests that it belonged to a tradition with deeper roots, perhaps influenced by even older centers lost to time. Instead of a civilization ascending gradually, the Maya may have inherited knowledge from an earlier cultural horizon, one that remains invisible in the archaeological record. The 2025 discovery does more than expand the map of ancient Mesoamerica. It challenges the idea that civilizations rise slowly through incremental innovation. Instead, it suggests that societies may leap forward when conditions align,
bringing together ideas, knowledge, resources, and belief in ways that traditional models cannot predict. Hidden beneath thousands of years of jungle, the lost Mayan city stands as a reminder that the past is far larger, older, and more complex than modern maps allow. And as LiDAR continues to penetrate the canopy, this city may be only the first of many revelations, each one pushing the origins of civilization deeper into the unknown. The newly revealed Mayan city in Guatemala does more than expand the archaeological map. It disrupts the entire structure of Mesoamerican history. For decades, scholars believed they understood how the Maya evolved. Small farming villages gradually expanded into regional centers, which slowly grew into the great cities of the Classic period. But the city uncovered by LiDAR in 2025 refuses to follow that timeline. Its scale, planning, and engineering appear fully mature, not experimental or transitional. Instead of a civilization finding its footing, the city looks like one already standing firmly on it. The biggest challenge lies in the city's age. The structures appear centuries older than the recognized rise of major Mayan centers. If this city was already complex by 1000 BCE or earlier, it means that the foundational stages of Maya society must have begun long before. Agriculture, leadership structures, engineering techniques, and ceremonial practices would all need to be pushed back in time. Such a shift requires rewriting textbooks, re-evaluating excavation data, and reconsidering how researchers interpret early pottery, tools, and artifacts across the region. This discovery also undermines the idea that early Mesoamerican societies developed in isolation. The presence of long causeways, defensive walls, and reservoirs suggests that the city was part of a wider network, exchanging goods, ideas, and possibly people with nearby regions. These connections imply shared cultural frameworks, intercity communication, and coordinated planning long before historians believed such systems existed. It also raises a new question. Were there even older cultural centers that influenced this city, now lost beneath jungle, river sediment, or volcanic layers? Another contradiction emerges from the architectural style. Many features of the newly uncovered city, stepped platforms, central plazas, ritual alignments, mirror the design patterns of much later Maya sites. If these forms already existed so early, it means the Maya developed their architectural identity quickly, passed it down consistently, and maintained it across centuries. This stability is unusual. Most civilizations evolve their architectural language gradually. Here, the Maya appear to have begun with a sophisticated template that endured over time. Such preservation suggests a strong cultural memory or inherited knowledge. The city's water systems are among the most surprising findings. The reservoirs and channels detected via LiDAR show planned hydrological engineering, designed to control seasonal rainfall and ensure stable water supply. These systems are remarkably similar to those used by the later classical Maya. Their presence in an earlier era demonstrates that the Maya mastered environmental management far sooner than expected. This contradicts long-held theories that climate fluctuations pushed the Maya to innovate their water systems. Instead, they may have possessed this expertise from the very beginning. The absence of inscriptions adds another layer of mystery. Classic Maya cities are known for their writing, sophisticated glyphs carved into stone monuments. But in this newly discovered city, no clear inscriptions have yet been exposed. This could mean that writing had not been developed at the time, or it could mean that writing existed in perishable forms, painted murals, wooden tablets, bark paper books that were reclaimed by the forest. If carved inscriptions eventually emerge, they could push back the origin of Maya writing by centuries and reveal early mythologies, kings, or cosmological beliefs. Why then was this city not included in any historical record? The answer lies in the environment. Over centuries, thick jungle swallowed the structures completely. Roots destabilized walls, trees toppled buildings, soil accumulated. With every generation, the forest grew denser until nothing remained visible to the human eye. For centuries, the city existed in silence, its presence hinted only by slight mounds and unnatural rises in the terrain. Without LiDAR, its rediscovery would have taken decades or perhaps never occurred at all. The implications reach far beyond Guatemala. If one major early city lay hidden so completely, others may be concealed in neighboring regions: Belize, Honduras, Mexico, El Salvador. The 2025 discovery suggests that Mesoamerica may hold many more lost capitals waiting beneath the canopy. With each site revealed, the origins of Maya civilization could move further back in time, revealing an early era of experimentation, innovation, and cultural unity that archaeology has barely touched. The discovery also challenges the popular narrative that early Maya societies were simple and rural. Instead, this city suggests that large populations existed earlier, with organized labor forces, administrative oversight, and complex social hierarchies. Temples, roads, and reservoirs require leadership. Leadership requires belief systems. Belief systems require cultural maturity. The mosaic of evidence points toward a people who were already thinking symbolically, communicating across distances, and planning for the future long before written history begins. Perhaps the most striking consequence is how this discovery reshapes our understanding of the Maya as innovators. The civilization long admired for its astronomical knowledge, mathematics, and engineering now appears to have roots deeper than anyone expected. Instead of rising slowly, the Maya may have experienced early bursts of development, moments of rapid growth driven by ideas, collaboration, and shared identity. This city, once silent under the jungle, now speaks loudly. It tells us that Mesoamerican history is incomplete, that the Maya were more advanced earlier than scholars believed, and that human ingenuity often appears suddenly, without warning, in places where few expect it. And as LiDAR continues to scan the forests, the next discovery may push the boundaries of civilization even further into the past. Across the barren, sun-bleached landscape of Peru's Nazca region lies one of the most perplexing archaeological enigmas on Earth: the Band of Holes. Stretching for nearly a mile across rugged desert terrain, this linear formation of more than 6,000 pits has puzzled researchers for over 60 years. They are too uniform to be natural, too orderly to be accidental, and too extensive to be explained by any simple singular purpose. The closer archaeologists examine them, the more mysterious they become. Each hole measures roughly the same size, about 1 meter wide and 1 meter deep, carved into rocky ground that is notoriously difficult to excavate. The line of pits runs along the slope of a natural ridge, following the terrain with mathematical consistency. Yet the formation begins and ends abruptly, with no signs of accompanying structures or settlements. For decades, scholars proposed theories ranging from granaries to defensive trenches to burial markers. None fit the evidence. The most striking feature is their sheer number. 6,000 holes require planning, labor, and a reason. Whatever culture created them invested significant effort into an inhospitable region with little water, little vegetation, and no obvious resources. This challenges the belief that early Andean communities focused only on agriculture and habitation. Instead, it suggests a deeper level of organization, a society capable of large-scale coordinated projects far earlier than expected. When the Band of Holes was first documented in the 1930s, aerial photography was still in its infancy. The formation appeared so strange that some researchers dismissed it as a natural erosion pattern. But boots-on-the-ground analysis quickly proved otherwise. The pits are carved, not eroded. They possess consistent edges and shapes that reflect deliberate human action. Later studies showed that the holes often contain smooth surfaces and regular depths, suggesting standardized techniques. Yet despite decades of research, the Band of Holes offers almost nothing in the way of supporting evidence. There are no inscriptions, no artifacts, no nearby settlements, no roads connecting the formation to known trade networks. The site sits in silence, as if its creators vanished without leaving any trace of their daily life. Some early theories proposed that the pits were storage units for agricultural surpluses, but storing food in open, exposed holes in one of the driest places on Earth makes little sense. Others suggested defensive structures, yet the pits form a line too narrow to halt any invading force. The burial theory also fails. Very few human remains have been found, and the holes lack the structure typical of tombs. Satellite imagery and drone scans have only deepened the mystery. The pits appear arranged in clusters that vary between single file and multiple parallel lines. In some areas, they form tight groupings. In others, they spread out slightly, though still within a defined path. Such variations may reflect different purposes, different time periods, or different cultural groups. But without artifacts, dating the holes accurately remains difficult. Radiocarbon tests offer only indirect estimates, suggesting the feature may be thousands of years old, possibly older than the Nazca lines themselves. One of the most compelling questions is why the pits follow the ridge. The formation moves with the natural shape of the land, suggesting that the terrain itself held significance. Some researchers believe the ridge functioned as a boundary marker. Others argue it may have been part of a ritual pilgrimage route, with each pit representing an offering site. These ideas remain speculative, but they highlight a key insight. The Band of Holes may not have been practical at all. It may have been symbolic. Ancient Andean cultures often expressed cosmology through large-scale landscape modifications, geoglyphs, ceremonial roads, and earthworks aligned with mountains or stars. The Nazca lines, located nearby, are perfect examples. The Band of Holes could belong to this broader Andean tradition of shaping the land to reflect belief, identity, or celestial order. The holes might have served as markers for astronomical events, ritual counting systems, or territorial claims. Their uniformity and scale support such interpretations. Recent analysis suggests the pits exhibit patterns similar to tally systems. Some clusters resemble counting sequences used in early Andean accounting, though no direct evidence connects them to quipu, the natpu, the knotted string records used by later Inca civilizations. If the Band of Holes functioned as a massive counting or tracking system, it would imply a level of administrative oversight far earlier than expected in this region. Drone footage also shows that certain sections of the formation widen, as if accommodating larger gatherings or emphasizing specific points along the ridge. These areas could have been communal spaces for ritual activity, trade exchanges, or ceremonial passage. Such features support a growing theory among researchers that the Band of Holes was once part of a prehistoric marketplace or distribution system, a concept that will be explored more deeply in the next part. For now, the site remains one of the most enigmatic features of the ancient Andean world. Its purpose, creators, and meaning are lost to time.
Yet the sheer effort required to carve 6,000 pits into unforgiving desert terrain makes one thing clear. The people who built the Band of Holes were capable of organizing large-scale labor for reasons far more complex than simple survival. Their motivations, ritual, economic, or symbolic, hint at a society that understood order, measurement, and planning long before history recorded their existence. For more than half a century, the Band of Holes remained one of archaeology's strangest puzzles, an immense formation with no clear purpose, no artifacts, and no cultural context. But in recent years, a new interpretation has emerged, one that reframes the site not as a ritual mystery or defensive structure, but as a sophisticated system of commerce. If correct, this idea would mean that ancient Andean societies were far more economically organized than previously believed, managing trade, inventory, and distribution long before the rise of empires like the Inca. The key to this theory lies in the pattern of the pits. When researchers mapped the entire formation using drones and high-resolution satellite imagery, they noticed that the pits were not uniform across the entire ridge. Some clusters appear tightly spaced, almost like units in a row. Others are arranged in staggered patterns, and a few sections widen slightly before narrowing again. This variation suggests that the holes served different functions, perhaps corresponding to different types of goods, weights, or measurement categories. The ridge itself offers another clue. Positioned along a natural route between highland and coastal regions, the Band of Holes occupies a strategic location where ancient traders would have traveled. The surrounding region contains archaeological sites associated with early Andean cultures known for exchanging cotton, fish, maize, obsidian, and textiles. If the ridge served as a checkpoint or distribution hub, the holes could have functioned as standardized slots for sorting, counting, or evaluating goods. This idea aligns with early Andean practices. Later civilizations, such as the Inca, used quipu to record quantities and transactions. Andean societies also built tampu, way stations along trade routes, for storing and organizing food and goods. While the Band of Holes predates these practices by many centuries, it could represent a precursor to the same administrative mindset, a physical ledger carved into the landscape. One of the strongest arguments for a trade-related function comes from the uniformity of the pits. Most are roughly the same width and depth, implying standardization. Standardization is not a feature of ritual sites, which typically feature symbolic variation. It is, however, essential for inventory systems. Placing goods of comparable size or quantity into identical pits would make counting and tracking far easier for administrators. The sheer number of pits, more than 6,000, suggests large-scale activity, not occasional ceremonial use. Archaeologists examining soil samples inside the pits found traces of organic material, though too degraded to identify. Some pits contained slight discolorations consistent with temporary storage rather than long-term burial. If goods such as food, textiles, or trade commodities were placed in the pits briefly, perhaps during counting, taxing, or redistribution, this would explain the lack of preserved artifacts. The pits were never meant to hold objects permanently. Another possibility is that the pits served as markers for labor contributions. In ancient Andean societies, individuals or families often paid obligations, such as taxes or communal duties, through labor or goods. Each pit could have represented a unit of contribution, checked off or filled temporarily as work was completed. Such systems existed during the Inca period, but their roots may reach far deeper. Some researchers propose that the Band of Holes could have functioned like a massive open-air spreadsheet, with each pit representing a record. Traders or community members may have moved goods from pit to pit during inspection, assessment, or distribution. The ridge's visibility across the landscape supports this idea.
It would have been easy for overseers to monitor activity from above, organizing work efficiently. The site's design also hints at coordinated effort. The pits follow the ridge in a continuous line, reflecting a deliberate choice rather than random excavation. If the ridge was a recognized boundary or checkpoint, carving the pits directly along its spine would reinforce its significance as a place of control and evaluation. The linear layout could have allowed goods to be processed systematically, moving from one end of the ridge to the other. This economic interpretation does not eliminate symbolic meaning. In the ancient Andes, practical and spiritual functions often overlapped. A trade distribution center could also have served ritual purposes, perhaps invoking protection for travelers, blessings for goods, or symbolic alignment with nearby geoglyphs. The Band of Holes lies within a landscape saturated with sacred meaning, and its builders may have blended commerce with cosmology. What makes this theory particularly compelling is how it reframes early Andean societies. Instead of simple farmers or isolated groups, they appear as organized communities engaged in regional trade with standardized methods of accounting. If the Band of Holes was indeed a prehistoric marketplace or distribution hub, it predates similar systems in Egypt, Mesopotamia, and China. It implies the existence of administrators, strategists, and specialists long before the Andes developed large political states. The economic model also explains why no structures or settlements surround the ridge. Trade hubs often occupy neutral ground, not domestic zones. Temporary gatherings, seasonal exchanges, or periodic inspections would leave little trace. Once activities ceased, the pits remained as silent evidence of a sophisticated system that no longer needed them. While the Band of Holes may never reveal its full story, viewing it as a forgotten commercial center brings coherence to its features, its scale, its standardization, its strategic placement, and its enduring mystery. It suggests that ancient Peruvians were not just carving symbols into the desert. They were organizing labor, managing resources, and maintaining a trade network so important that they etched its structure directly into the land itself. In the remote interior of Australia, far from the continent's coastlines and modern cities, lies a site so old and so unexpected that it disrupts the entire timeline of human presence in the region. Known as the Boscombe locality, this site contains evidence of human activities stretching back more than 40,000 years, making it one of the oldest cultural landscapes on the planet. Yet for decades, it remained overlooked, its significance underestimated, its features misinterpreted. Only in recent years have researchers begun to understand how profoundly it challenges conventional ideas about the capabilities of early humans in Australia. The site first gained attention when archaeologists studying surface formations noticed patterns that did not match natural erosion. Smooth stone surfaces, deliberate cut marks, and unusual arrangements of fragments suggested a level of intentional modification rarely associated with Pleistocene-era populations. Initial excavations uncovered stone tools that were impossibly old, older than many early human sites in Europe, Africa, or Asia. But the most striking features were the worked stones themselves, slabs shaped with precision, grooved edges, and surfaces polished through repeated deliberate contact. According to traditional archaeology, humans 40,000 years ago were expected to leave behind simple tools, flakes, hammerstones, and basic scrapers. But Boscombe revealed something very different. The stoneworking techniques exhibited here show controlled flaking, pattern shaping, and surfaces that appear engineered to fit specific functions. These characteristics suggest planning, repeated practice, and knowledge passed across generations. The skill on display implies not just survival-level toolmaking, but a deeper understanding of material properties. This realization forces researchers to question long-held assumptions about early Australians. For decades, textbooks portrayed them as isolated hunter-gatherers who developed cultures slowly over time. Yet the site's complexity suggests that early humans in Australia may have possessed higher technological capabilities than previously recognized. The presence of structured stone edges, some almost straight enough to resemble later grinding grooves, hints at early experimentation with techniques that would not become widespread until thousands of years later. What makes Boscombe even more mysterious is the lack of clear settlement evidence. Like Göbekli Tepe and Karahantepe, the site reveals advanced craftsmanship without accompanying domestic structures. No houses, no hearths, no agricultural remains. Instead, Boscombe feels like a specialized location, a workshop, ceremonial site, or place of practical innovation used episodically by groups who traveled across the landscape. This pattern suggests a mobile culture that still carried significant knowledge, organizing tasks and passing skills from one generation to the next. The geological context adds an even deeper layer of intrigue. The stones used at Boscombe are not random. They were selected from deposits with specific mineral qualities. This indicates that the people who worked here understood which rocks were best for flaking, polishing, and shaping. Some fragments show evidence of heating, a technique used to enhance the workability of stone. Heat treatment is typically associated with much later prehistoric toolmaking traditions, yet here it appears tens of thousands of years earlier. The implications ripple beyond Australia. If humans in this region possessed advanced stoneworking skills 40,000 years ago, then global models of human technological evolution may be incomplete. It suggests that early innovation did not move in a single line from Africa to Europe to Asia. Instead, multiple human populations may have developed complex technologies independently, responding creatively to their environments. Even more compelling is the possibility that Boscombe served as a knowledge transfer site. The presence of repeated tool types, consistent flaking patterns, and standardized shapes suggests cultural continuity, a community teaching specific methods to newer generations. This continuity challenges the belief that early Australian populations lived in small, isolated groups. Instead, they may have maintained broader networks of communication across the continent. The site also raises questions about early symbolism and ritual. Some stone arrangements resemble circular patterns found in other ancient cultures, though not enough evidence exists to confirm ceremonial intent. Still, the placement and selection of stones hint at a relationship with the landscape, perhaps seasonal gathering, resource management, or spiritual significance tied to natural formations. One of the biggest mysteries is why Boscombe remained overlooked for so long. Part of the answer lies in the vastness of the Australian interior. Many ancient sites remain buried or eroded, hidden beneath shifting sands or overgrown by vegetation. Without intensive mapping technologies or targeted excavation, such places can remain invisible for centuries. Only when researchers revisited the site with new scientific methods, microwear analysis, mineralogy, and high-definition mapping, did the true nature of the stones become clear. The Boscombe site forces us to reconsider what early humans in Australia were capable of. Far from being primitive, they may have been innovators, experimenting with tools, modifying stone, and transmitting knowledge across distances. Their legacy has been scattered by time, but the stones they shaped carry echoes of a world more complex than archaeology once believed. The revelations emerging from Boscombe do not stand alone. They form part of a growing pattern across the globe, evidence that early humans possessed skills, intelligence, and organization far above the levels assigned to their era. And as researchers continue to excavate deeper and analyze the stonework more closely, each new discovery pushes the origins of complex behavior further into the past. The Boscombe site is more than an archaeological curiosity. It is a direct challenge to the belief that early humans in Australia relied solely on simple flaked tools. As researchers began analyzing the stone surfaces and fracture patterns in detail, a new picture emerged, one that suggests an unexpectedly advanced understanding of stone engineering. Some surfaces are so finely shaped that they resemble later grinding grooves, while others show edges sharpened with techniques long believed to have developed millennia afterward. It is as if a forgotten technological phase existed here, far earlier than the archaeological timeline allows. The most compelling evidence comes from microscopic analysis. Under high magnification, the worked stones reveal repeating patterns of controlled pressure flaking, small, deliberate removals arranged so precisely that they form near straight edges. These patterns are not random. They require knowledge of how stone fractures under force, how to angle blows correctly, and how to maintain symmetry. Modern knappers recognize these patterns as belonging to skilled craftsmanship. But Boscombe's oldest layers date back 40,000 years, suggesting that such techniques existed incredibly early in human history. Some stones also show signs of intentional polishing. The smoothness is too consistent to result from natural abrasion. Instead, it appears produced by repeated, directed movement against another material, possibly for grinding plant matter or shaping wooden implements. Polishing requires time and planning, implying the site served specific, repeated functions. If early Australians were using stones not just as cutting tools but as shaping, smoothing, and grinding instruments, it means they possessed a more diverse technological toolkit than previously assumed. Another surprising feature is the evidence of heat treatment. In several samples, mineralogical changes indicate that stones were heated to controlled temperatures before being worked. Heat-treating stone makes it more workable, a technique found in much younger prehistoric cultures across the world. The fact that it appears here, in one of the oldest known Australian contexts, suggests that these early communities experimented with materials in ways modern archaeology did not expect. The organization of the site adds to the mystery. Instead of scattered tools left behind by nomadic groups, Boscombe contains clusters of similarly shaped objects, suggesting designated work areas. Some clusters include stones that fit together or show sequential working stages, roughing, shaping, refining, indicating a structured process. This points toward a workshop-like environment, used repeatedly across generations. The consistency of technique across thousands of years hints at cultural continuity, perhaps a tradition of teaching and learning passed from elders to younger members of the community. This contrasts sharply with the long-held assumption that early Australians lived in isolated bands with limited contact. Instead, the Boscombe evidence implies networks of knowledge sharing, long-distance communication, or periodic gatherings where techniques were taught, refined, and standardized. It suggests the existence of intangible cultural infrastructure, systems of training, memory, and practice that do not survive in the archaeological record, but shaped the capabilities of these ancient populations. The stone grooves and polished surfaces also invite another possibility, that some features served symbolic or ceremonial functions. While the site lacks the monumental architecture seen in places like Göbekli Tepe, certain arrangements, circular placements, aligned fragments, repeating forms, hint at intentional spatial design. Some archaeologists propose that stone arrangements may have been used for ritualized activities, teaching demonstrations, or communal events tied to seasons or migrations. Environmental evidence supports the idea of periodic gatherings. The region around Boscombe contains water sources, seasonal food, and vantage points overlooking wide stretches of land. Such a location could have served as a meeting ground for different groups who brought resources, exchanged knowledge, and practiced stoneworking techniques. These gatherings may have reinforced cultural identity and ensured the preservation of technological skills across generations. The site also raises questions about early cognitive development. The ability to understand fracture mechanics, select appropriate rock types, heat-treat material, and execute precise shaping reflects advanced problem-solving and planning. It suggests that early humans in Australia had already developed complex mental models of cause and effect, models traditionally associated with later agricultural or urban societies. Boscombe demonstrates that intelligence and innovation did not begin in Mesopotamia or Egypt. They were part of the human story long before, emerging in parallel across the globe. Yet even with these revelations, Boscombe remains largely invisible in public awareness. Its age and subtle features make it easy to overlook, especially when compared to more dramatic archaeological sites worldwide. But its significance lies precisely in its subtlety. It shows that sophistication does not always take the form of monumental temples or carved stone faces. Sometimes it appears in the quiet precision of a worked stone, the decision to heat a tool, or the careful planning behind a polished surface. What makes Boscombe truly extraordinary is how much it suggests about humanity's forgotten technological past. Rather than a slow, linear development, the evidence points toward early bursts of innovation followed by periods of loss or transformation. Knowledge, once mastered, may have been abandoned, relocated, or replaced as populations moved across vast landscapes. As researchers continue to study the site with new technologies, 3D modeling, residue analysis, and advanced mineralogy, Boscombe may reveal even deeper layers of prehistoric ingenuity. It has already changed the narrative of early Australia, and by forcing us to reconsider what early humans were capable of, it adds to a growing global realization. The roots of human intelligence stretch far deeper into the past than we ever imagined. Across Southeast Asia, scattered among caves, river valleys, and forgotten rock shelters, lie markings that defy classification, symbols carved or painted long before the rise of any known writing system. These inscriptions do not belong to Brahmi, Khmer, Chinese, or any recognized linguistic family. Instead, they represent a lost script, or perhaps multiple scripts, created by ancient societies whose identities have vanished. Their discovery challenges one of archaeology's most fundamental assumptions, that writing emerged late, after agriculture and states had already taken shape. Yet the evidence hidden in the forests of Indochina suggests that symbolic recording may have begun far earlier than scholars expected. The earliest hints of this forgotten writing came from remote limestone caves in Laos and Vietnam. Researchers found repeated symbols, cross-hatched lines, spiral forms, intersecting strokes, and grid-like patterns, etched with deliberate precision. These were not random marks or decorations. Their placement, repetition, and structure resembled early attempts at recording information. Some symbols appear in clusters, arranged horizontally as if forming sequences.
Others appear vertically, resembling tally or ledger formats. Yet none match the features of known proto-writing systems like those from Mesopotamia or China. What makes these symbols so compelling is their age. Some are estimated to be more than 4,000 years old, predating established scripts in the region by centuries. This contradicts the long-held belief that Southeast Asia adopted writing only after influence from India or China. Instead, the markings suggest that indigenous groups developed their own recording systems that existed before historical kingdoms arose. More evidence surfaced along riverbeds in Cambodia and Myanmar, where researchers documented carved stone surfaces featuring repeated geometric shapes. Some surfaces include parallel strokes that vary in length and spacing, possibly representing quantities or measurements. Others show enclosed shapes, circles, squares, diamonds, each carved with similar depth and technique, implying standardized meaning. While these motifs are too early to be linked directly to the Angkorian or Pu cultures, they hint at a deep cultural lineage of symbolic communication. The consistency across sites is striking. From Vietnam's mountain caves to Laos's remote plateaus, from northern Thailand to the banks of the Mekong, the same families of symbols appear. The broad geographical spread suggests that the script, if it can be called a script, was part of a shared cultural tradition. Whether it represented language, ritual symbols, trade records, or astronomical observations remains unknown, but its distribution implies that ancient Southeast Asian societies communicated symbolically across long distances. The challenge lies in interpreting the symbols. Without a bilingual inscription, like the Rosetta Stone, that unlocked Egyptian hieroglyphs, archaeologists have no key to deciphering these marks. Their meaning is frozen in stone, unreachable. Some researchers believe they record seasonal information, flood cycles, hunting routes, or agricultural schedules. Others propose they functioned as mnemonic devices, helping storytellers preserve oral history. A few argue that the symbols reflect early cosmology, representing stars, directions, or ritual pathways. Each theory fits part of the evidence but fails to explain it all. The marks also show variation in technique. Some are carved with stone chisels, leaving deep, confident lines. Others are painted with mineral pigments that have survived for millennia on cave walls. The pigments contain iron oxide, charcoal, and clay, a mixture indicating purposeful preparation. The use of pigment suggests that the markings held ceremonial or communal significance. People returned to these caves repeatedly, adding new symbols, preserving old ones, layering meaning across generations. What makes the mystery even more compelling is the absence of accompanying artifacts. No tablets, tools, or objects containing similar symbols have been found outside natural rock surfaces. This suggests the script may have been restricted to specific locations, caves, stone outcrops, sacred shelters, rather than used for daily administration. If so, it may represent an early form of ritual writing, where the act of inscribing was more important than the record itself. The geographic isolation of Southeast Asia further complicates the puzzle. For many years, scholars believed that early civilizations in the region developed in relative isolation, influenced more by external powers than internal innovation. Yet, the symbols carved into these stones paint a different picture, one of indigenous development, creativity, and intellectual expression long before the rise of large kingdoms. These marks reveal a world in which people engaged with abstraction, counting, measuring, symbolizing, long before writing was formalized. Some of the symbols also appear in association with ancient burial sites. Patterns carved onto grave markers resemble those found in distant caves,
suggesting that the markings held spiritual meaning. They may have represented clan identities, ancestral names, or cosmological beliefs tied to life and death. If true, the script was not merely functional, it was deeply woven into the emotional and spiritual fabric of early communities. Attempts to compare the script with known proto-writing systems have yielded mixed results. Some sequences resemble tally marks found in early Chinese records. Others echo grid patterns used in Neolithic Europe. Yet the Southeast Asian symbols remain uniquely structured, reflecting an independent intellectual tradition rather than borrowed concepts. Their presence challenges the idea that writing evolved in a single cradle and spread outward. Instead, multiple societies across the ancient world may have experimented with symbolic communication independently. The lost script of ancient Indochina remains unreadable, a silent testimony to the creativity of early human communities. It forces us to question what writing truly is, whether it begins with full linguistic encoding or whether early humans developed hybrid forms of memory, record-keeping, and symbolism that existed between art and language. Whatever these symbols once meant, they reveal a simple truth. The people who carved them were thinkers, observers, and communicators. They left behind fragments of a worldview now obscured by time, inviting us to rediscover a chapter of human history that has yet to be written. The mysterious symbols scattered across Southeast Asia present archaeology with a problem that cannot be solved by excavation alone. They are clear enough to suggest meaning, repeated enough to imply structure, but isolated enough to remain beyond interpretation. Modern researchers stand in front of these carvings without a key, facing a system of communication that was never translated, never preserved, and never carried into recorded history. It is a silent language, one that forces science to confront the limits of its own methods. One of the greatest challenges is the absence of context. Ancient writing systems only become legible when scholars can compare them across mediums, objects, or historical references. Egypt had monumental inscriptions, papyri, and temple walls. Mesopotamia had tablets and repeated administrative records. But the Southeast Asian symbols live almost entirely on cave walls and stone surfaces. Without accompanying tools, pottery, or standardized artifacts, the symbols exist in a vacuum. This lack of context means that even if the same symbol appears dozens of times, its meaning remains locked. More troubling is that previous attempts at interpretation relied too heavily on assumptions. For years, scholars tried to link the markings to later scripts that developed in Southeast Asia. However, linguistic analysis shows no clear relationship. The symbols do not match any Brahmi-derived alphabets, nor do they resemble early Chinese characters. They appear to represent a separate intellectual tradition, one that did not survive long enough to influence later civilizations. This possibility forces researchers to consider that entire writing systems may have emerged and vanished without leaving a mark on the historical record. The isolation of the script also highlights a major weakness in current archaeological models. Science often assumes that writing emerges only after agriculture leads to administration and record-keeping. This means that early scripts should be found in places with stable settlements and growing populations. But the Southeast Asian symbols appear in caves, cliff overhangs, and remote stone shelters. These locations were not administrative centers. In some cases, they were seasonal or ritual spaces. The presence of symbols in such locations challenges the idea that writing must begin as a bureaucratic tool.
Instead, early humans may have used symbols to encode memory, identity, and cosmology long before large-scale societies needed records. Another striking insight comes from studying the techniques used to create the symbols. Some carvings show multiple layers of reworking, suggesting that later visitors returned to specific symbols and inscribed them again, reinforcing their importance. Others appear intentionally preserved, with newer markings placed beside older ones rather than on top of them. This pattern suggests that the ancient communities who created these symbols valued continuity and recognized the significance of earlier inscriptions. Such behavior indicates collective memory and respect for tradition, qualities usually attributed only to later civilizations. The script also reveals how fragile cultural knowledge can be. A writing system is only as strong as the community that uses it. Once the community disappears, the script disappears with it. Floods, migrations, conflict, or climate change could have disrupted the societies that used these markings. If their population declined or relocated, the script may have faded in a single generation. This raises a profound question. How many early writing systems have been lost simply because their communities were too small to withstand environmental or social changes? Another lesson comes from comparing the symbols across different sites. Although the shapes remain similar, their placement varies. Some sites feature horizontal sequences, suggesting narrative or list-like structures. Others place symbols vertically beside carved shapes that resemble early cosmological diagrams. This variation indicates that the script may have served multiple purposes. It could have functioned as a teaching tool, a ritual language, or a mnemonic aid for oral storytelling. Instead of a single meaning, the symbols may have carried layered significance, understood differently depending on the community or occasion. The script also challenges the assumption that writing must evolve toward complexity. Many modern alphabets began as detailed pictographs and gradually simplified. But the Southeast Asian symbols remain consistently abstract. They do not become more pictorial over time. This suggests the script was created by societies that valued abstraction and symbolic thinking, not literal representation. In this way, the script resembles early counting systems or ritual symbols more than formal writing. This raises the possibility that the markings were designed to trigger memory rather than record full language. Perhaps the most important lesson from this undeciphered script is what it reveals about human cognition. The ability to create symbolic systems is not tied to cities, agriculture, or states. It is tied to the human mind. People carve symbols because they want to capture meaning, preserve memory, and connect with something larger than themselves. The Southeast Asian script demonstrates that early humans were capable of these impulses long before the rise of formal civilizations. In many ways, the script stands as a monument to the complexity of prehistoric societies. It reminds us that history is uneven, that knowledge rises and falls, and that intellectual breakthroughs can appear anywhere, at any time. The people who made these symbols were not primitive. They were thinkers, observers, and creators who built a symbolic world we can barely glimpse today. While we may never read their words, the existence of this forgotten script expands our understanding of early humanity. It shows that the story of writing is not linear, but scattered, filled with lost chapters and vanished traditions. And somewhere behind these markings lies a worldview that once shaped lives, rituals, and memories, waiting quietly for someone to decipher what time has hidden. Across the ancient world, Agriculture is supposed to follow a predictable pattern. Small groups settle near rivers, experiment with planting, and gradually transform into farming communities over thousands of years. Yet new discoveries scattered across the globe reveal that prehistoric societies may have developed advanced agricultural techniques long before the traditional timeline allows. These findings point to a forgotten era when early humans understood plants, terrain, water, and seasonal cycles with surprising sophistication, challenging the belief that agriculture emerged slowly and only in specific cradle regions. In remote valleys of Southeast Asia, archaeologists have uncovered terraced fields far older than expected. Layered into mountain slopes, these terraces show careful engineering and soil management, suggesting that early communities understood erosion control and long-term cultivation. Soil samples indicate that these fields once supported a variety of crops, including early forms of millet, tubers, and leafy greens. Such evidence pushes back the age of agriculture in the region by centuries and implies that human groups were farming while still maintaining mobile lifestyles. What surprises researchers most is the level of planning required to build these terraces. Constructing even a small system demands knowledge of slope stability, water flow, and soil composition. The terraces discovered in these ancient valleys extend for hundreds of meters, curving with the contours of the land. They were clearly not the product of isolated experiments, but part of a coordinated effort that spanned multiple generations. This suggests that prehistoric farming communities were capable of large-scale landscape transformation long before villages and permanent settlements appeared. In other regions, such as the highlands of Papua and parts of South America, early irrigation systems present another challenge. Channels cut into earth and stone carry water from higher elevations into lowland fields with mathematical precision. These channels are not accidental. They reflect a deep understanding of hydrology, ensuring that water flows steadily without eroding soil or flooding crops. Some irrigation lines are so well preserved that they continue to direct water today. Their age makes them even more astonishing. Carbon dating of associated organic material places some systems at more than 5,000 years old, predating known agricultural states in the region. These discoveries force scholars to rethink the relationship between farming and settlement. The traditional view assumes that agriculture leads to villages, but many early systems show evidence of being maintained by communities that did not live permanently on site. Instead, groups may have visited the fields seasonally, tending crops as they moved across the landscape. This seasonal farming model supports the idea that early humans were adaptive and mobile, capable of managing complex agricultural systems without relying on permanent architecture. Another mystery arises from the botanical remains found in prehistoric sites. Some seeds show genetic variation that appears too intentional to be natural. This suggests early domestication efforts well before agriculture became widespread. In certain cases, plants exhibit traits like larger seed size or thinner husks, changes usually linked to human selection. These traits hint that early communities were experimenting with plant breeding much sooner than expected, refining crops slowly across centuries through observation and preference. Even more remarkable are the signs of deliberate soil enrichment. In several ancient farming regions, researchers have discovered patches of dark, nutrient-rich earth that differ sharply from the surrounding soil. These patches contain charcoal, fish bones, plant matter, and mineral fragments mixed in deliberate proportions. The presence of charcoal suggests early use of controlled burning to enhance soil fertility. Such techniques resemble later methods like Amazonian terra preta, a highly fertile anthropogenic soil created through intentional enrichment. If early humans were enriching soil thousands of years earlier than thought, it implies a deep understanding of ecological cycles.
The sophistication of these early systems raises questions about their origins. Did communities independently develop agricultural knowledge in multiple places at once? Or did ideas spread through long-distance networks of contact and exchange? Either scenario challenges the classic model that places the invention of agriculture in a small number of regions, spreading outward over time. Instead, agriculture may have emerged in parallel across various landscapes, each shaped by local needs and creativity. Prehistoric farming also reveals how experimental early humans were. Evidence from grinding stones, hearths, and storage pits shows that people tested different plant species, learning through trial and error which seeds germinated quickly, which roots stored well, and which leaves could survive dry seasons. This experimental nature suggests a culture of curiosity, not simply survival. Early humans were not passive foragers waiting for chance discoveries. They were observers, innovators, and long-term planners. Perhaps the most striking implication is how these agricultural systems reflect early knowledge of climate. Channel placement, terrace orientation, and crop selection all indicate that prehistoric communities understood seasonal rainfall, monsoon cycles, and drought patterns. Such knowledge requires years of observation and reliable memory transfer. This challenges the idea that early humans were only loosely connected to the land. Instead, they read landscapes with precision, predicting environmental shifts and adapting accordingly. These discoveries show that long before the rise of kingdoms or cities, early agriculturalists were shaping their world with skill and intention. They cultivated not only crops but knowledge, passing it down in ways that left no written record but remained etched into the soil and stone. Their terraces, channels, and enriched earth stand as quiet evidence of a forgotten legacy, one that reveals how early humans were far more resourceful than the historical timeline suggests. While early agricultural systems reveal stunning technical skill, an even deeper layer of knowledge appears when researchers examine how prehistoric farmers aligned their work with the cycles of the sky. Across multiple continents, evidence shows that early communities tracked the sun, moon, and stars with remarkable accuracy, using celestial patterns to guide planting, harvesting, and ritual life. These findings contradict the idea that astronomy emerged only with advanced civilizations. Instead, they suggest that skywatching is far older and far more widespread than previously believed. In several ancient farming regions, terraces and irrigation channels align with specific solar events. In highland Southeast Asia, certain terraces face east in a way that catches the first light of the winter solstice. Others are angled to follow the path of sunrise during equinox periods. These alignments are too consistent to be accidental. Their purpose appears to be agricultural calibration. By reading the position of the sun on the horizon, early farmers could predict the start of rainy seasons or the arrival of dry months. This level of awareness allowed them to plant crops at optimal times, reducing the risk of failure. Further south, in ancient river valleys of Indonesia, researchers identified stone markers placed in lines that correspond to lunar cycles. Some markers appear spaced at intervals matching the length of lunar months. If these stones indeed track moon phases, this suggests that prehistoric communities used lunar calendars long before the appearance of written calendars. The moon directly influences tides, rainfall patterns, and the behavior of certain plant species. Farmers who tracked the moon could anticipate environmental changes with surprising accuracy. Other sites reveal alignments not only with the sun and moon, but with specific stars. In parts of Oceania, Early agricultural communities carved notches into stone ridges that frame the heliacal rising of certain constellations. The appearance of these stars in the dawn sky may have signaled seasonal transitions, migrations of animals, or ideal planting windows. Such stellar alignments show that early humans understood long-term cycles, possibly maintaining sky-based knowledge across generations through oral tradition. The sophistication of these alignments raises questions about how such knowledge was preserved. Without writing, communities likely relied on ritual, performance, and storytelling to transmit information about the sky. Some farming groups may have designated individuals responsible for observing celestial events. These observers would watch the horizon, track star positions, and communicate their findings to others. Over time, such traditions could become embedded in ceremonies, ensuring that the knowledge remained stable. This suggests a cultural structure capable of maintaining scientific memory even without formal institutions. One of the most intriguing aspects of ancient sky knowledge is how closely it ties to religious and symbolic expression. In many prehistoric societies, the movements of the sun, moon, and stars were not only practical guides but spiritual forces. Some terraces and channels appear oriented toward sacred mountains or horizon points associated with ancestral myths. This indicates that farming was not merely economic, it was cosmological. Early humans cultivated the land with an awareness that connected earth and sky, survival and meaning. Archaeologists studying early farming tools have found markings that may represent tracking systems. On some grinding stones and pottery fragments, sequences of dots or lines appear in repeating patterns. These may have served as early mnemonic devices to record lunar cycles or seasonal intervals. If so, they represent an early form of scientific notation, created long before written calendars emerged. The spread of ancient astronomical knowledge is also surprising. Similar alignments appear across continents with no known contact between cultures. Solstice-oriented structures show up in Japan, the Andes, Europe, and Indonesia. Lunar tracking stones appear in Australia and Africa. While these cultures developed independently, they reached the same conclusion. The sky is predictable. The cycles repeat. And mastering these cycles is the key to agricultural success. This global pattern suggests that skywatching is among the oldest scientific traditions of humanity, emerging naturally wherever people attempted to farm. Even small-scale agricultural experiments required careful timing. Without modern tools, communities turned to the most reliable clock available: the horizon. The agricultural significance of these alignments cannot be overstated. Planting at the wrong time could result in disastrous failure. But by synchronizing farming with celestial cycles, early humans dramatically increased their chances of survival. This connection between sky and soil forms the foundation of ancient agricultural calendars, many of which persist today in modified form. Festivals, harvest rituals, and seasonal ceremonies across the world still align with equinoxes or solstices, echoing prehistoric knowledge preserved through culture rather than writing. Another surprising detail emerges when analyzing the orientation of ancient water channels. Some channels are angled to maximize sunlight exposure, promoting evaporation or microbial activity beneficial to soil. Others appear designed to avoid direct sunlight, protecting stored water during hot seasons. These engineering choices may have been guided by generations of observing the sun's path.
Their precision reflects early mastery of environmental interactions, turning sky knowledge into practical design. Taken together, these discoveries reveal a forgotten intellectual tradition among prehistoric farmers. They were not simply experimenting with crops. They were scientists of the sky, reading its patterns with patience and recording its cycles through stone alignments, landscape design, and ritual practice. Their calendars, though unwritten, were accurate. Their observations, though unrecorded, shaped entire communities. This synergy between land and sky shows that early humans developed complex environmental understanding long before the rise of cities. It reflects a worldview in which time was not measured by tools, but by light and shadow, star paths and lunar rhythms. And while the specifics of these prehistoric calendars may be lost, the agricultural landscapes they shaped remain as evidence of a forgotten scientific legacy etched into the earth itself.
Across continents, separated by oceans, deserts, and thousands of years of cultural development, archaeologists keep encountering a strange pattern. Megaliths, temples, pyramids, and even humble stone foundations show measurements that appear standardized. Structures built by societies with no known contact often use repeating units of length, consistent ratios, and geometric relationships that seem far too advanced for their time. This shared mathematical fingerprint suggests that ancient humans may have understood measurement long before the rise of formal science. The idea is controversial because it challenges a fundamental belief that early humans built by instinct and approximation, not by mathematics. The first hints of this ancient measurement system surfaced when researchers studying megalithic sites in Europe noticed repeating dimensions. Stone circles in Britain, dolmens in France, and burial chambers in Scandinavia shared similar lengths despite vast cultural distances. These patterns were later found in structures across the Mediterranean, parts of Africa, and even Asia. Although each region used different materials and architectural styles, the underlying ratios remained consistent. The precision of these measurements indicates deliberate planning rather than coincidence. Similar clues appear in ancient construction platforms in the Andes. Despite being separated from Eurasia for tens of thousands of years, early Andean builders used modular stone blocks following predictable proportions. Some structures display near-perfect right angles and consistent block sizes. Others reveal geometric layouts based on simple but accurate ratios. These ratios sometimes match those found in Old World structures, raising questions about whether early humans independently derived the same principles or inherited knowledge from an unknown source. One of the most striking features is the consistency of a base unit. Across multiple regions, archaeologists have identified lengths that cluster around similar values when converted to modern measurements. While terminology differs and direct links cannot be proven, the pattern suggests that early humans often used a unit roughly equal to a fraction of their stride or arm span. The precision is remarkable considering the absence of written measurement systems. Builders appear to have used ropes, staffs, or marked stones to maintain accuracy across large projects. Such methods require not only skill but shared standards within a community. The presence of standardized units also implies training. Early builders would have needed to learn how to measure, check, and align structures. This suggests the existence of specialized roles long before the rise of professional architects or engineers. Communities must have valued accuracy enough to pass down techniques across generations.
The idea that small, scattered populations invested in precise measurements challenges the belief that mathematics only emerged once cities and complex institutions developed. Further evidence appears in ancient layouts based on geometry. Some prehistoric structures incorporate simple triangles, circles, and alignments that match cardinal directions. While these shapes are basic by modern standards, their consistent use across continents indicates intentional design. Aligning structures to north, south, east, and west requires tracking the sun. Creating right angles demands a reliable method of verifying the corner. Such techniques show that early humans did not stumble into measurement. They observed, tested, refined, and applied mathematical ideas to shape their world. Another clue lies in the durability of these measurement systems. Many ancient structures maintain their proportions even after millennia of environmental wear. This resilience reflects the strength of the underlying mathematics. Builders understood weight distribution, stability, and symmetry, even if they lacked formal terminology. Some megaliths appear positioned to reflect harmonic ratios. Others incorporate spacing that resembles early modular design. The most intriguing aspect is the global pattern. While there is no evidence of contact between early European, African, American, and Asian builders, they often reached similar mathematical solutions. This could mean early humans across the world developed parallel systems based on shared human experience, such as body proportions or horizon observations. Or it may reflect a deeper, forgotten intellectual tradition passed across generations long before the rise of written history. Archaeologists studying ancient tools have found measuring sticks marked with evenly spaced cuts. In some cases, strings twisted with regular intervals appear to have been used as ancient rulers. These tools hint that measurement was not improvised but systematized. Communities did not simply eyeball structures, they followed rules. The widespread presence of standardized measurement challenges two major assumptions. First, it refutes the idea that early construction was chaotic or unplanned. Second, it suggests that early humans possessed a shared mathematical awareness, even if their societies were thousands of miles apart. Ancient builders may not have recorded equations, but they clearly understood proportion, symmetry, and repetition. This raises a larger question. If measurement systems appeared so early, where did they come from? Did they arise independently in multiple places, driven by similar needs? Or do they represent the remnants of a much older intellectual tradition now mostly erased by time? Whatever the answer, the existence of standardized measurement across prehistoric structures reveals that ancient humans were far more skilled than the timeline suggests. Their understanding of proportion shaped the earliest monuments, landscapes, and settlements. And the simple tools they used reflect a mathematical legacy that predates writing, cities, and recorded science. The discovery of ancient standardized measurement systems is only half the mystery. The deeper question is how prehistoric builders applied these units with such accuracy when constructing massive monuments, temples, and engineered landscapes. Their work, still standing after thousands of years, reflects a level of precision that seems incompatible with the tools they are believed to have used. Yet the evidence is clear. Ancient structures were not assembled through guesswork. They followed rules, patterns, and geometric logic that modern researchers are only beginning to understand. One of the most striking examples comes from early stone foundations across Eurasia and the Americas. Builders consistently achieved straight lines, right angles, and perfectly spaced intervals.
Aligning a structure along cardinal directions requires tracking the movement of the sun across seasons. Creating a right angle demands a reliable method of verification, such as using ropes tied in proportional loops. Archaeological experiments show that early humans could have used simple geometric tricks to achieve this accuracy. What remains surprising is not the method, but the consistency. Entire regions adhered to the same geometric standards for centuries. More complex structures reveal even greater understanding. Ancient pyramids in multiple cultures show deliberate ratios between height, base length, and slope angle. Some reflect mathematical relationships such as proportions that match harmonic divisions. These are not accidental outcomes. Builders experimented with forms until they discovered which shapes offered maximum stability and aesthetic balance. Even without written formulas, they internalized these relationships through practice and tradition. The precision becomes even more apparent when examining stone joints in prehistoric sites. In certain Andean constructions, stones fit so tightly that a blade cannot pass between them. These stones were shaped by hand, using tools far simpler than modern chisels, yet the angles and contact points match perfectly. This implies measurement not just of length, but of angle and orientation. The builders understood how to transfer a measurement from one stone to another, indicating advanced spatial reasoning. Such reasoning requires mental models of geometry that go beyond simple trial and error. Similar engineering insights appear in ancient water systems. Irrigation channels from early agricultural societies follow gradients calculated to maintain consistent water flow. Too steep, and the water would erode the soil. Too shallow, and the flow would stagnate. The builders clearly knew how to measure slope and adjust their construction accordingly. In some cases, channels cut into stone maintain a uniform grade for hundreds of meters. Achieving this level of precision suggests ongoing surveying, marking, and recalibration during construction. Construction of large monuments required labor organization as well. Accurate building depends on shared standards among workers. If one group uses a different unit or method than another, the structure will not align. The consistency of ancient construction implies that communities trained builders in standardized measurements, teaching them to pass these techniques through apprenticeship. This form of teaching, though unwritten, reflects an intellectual tradition equal to that of later architectural schools. The presence of long-distance alignment adds another layer. Some ancient structures appear oriented toward distant mountains, horizon markers, or astronomical points. Creating such alignments requires the ability to measure over large areas, using sightlines, flags, or repeated measurements. This kind of surveying is normally associated with advanced civilizations. Yet it appears in societies that left behind no written records or evidence of formal institutions. Their knowledge was embedded in practice rather than texts. Archaeologists are also uncovering evidence that ancient builders used modular planning. Foundations reflect repeating units that allow a structure to be expanded logically. This modularity simplifies large projects and ensures proportional harmony. Modern architects use similar principles when planning multi-room structures. The fact that prehistoric builders applied modular thinking suggests cognitive abilities equal to later architectural civilizations. Some of the most interesting clues come from tools themselves. Marked stones, knotted cords, and measuring sticks indicate that builders had physical aids to maintain accuracy. These simple tools could be combined to create complex results. A rope with knots at even intervals can measure lengths, create squares,
form triangles, and even replicate ratios. In skilled hands, it becomes an all-purpose instrument capable of translating mental geometry into physical construction. The global distribution of these methods raises questions about how widespread mathematical thinking was in ancient societies. Did multiple cultures discover similar techniques independently, guided by common human experience? Or was there a deeper shared heritage of measurement knowledge passed through oral tradition long before history was recorded? Neither answer fits neatly within current models, but the evidence demands reconsideration of how early humans thought about space, form, and structure. The durability of ancient monuments is perhaps the strongest testimony to the quality of their mathematics. These structures endure earthquakes, erosion, and centuries of environmental change. Their proportions remain intact, their angles preserved, their symmetry visible from distances. Even when their builders vanished, their knowledge survived in the stones themselves. This persistence demonstrates that the principles guiding their construction were sound enough to withstand the harsh test of time. The deeper lesson in these ancient measurements is that early humans understood far more about the physical world than archaeologists once believed. They were not simple builders working by instinct. They were designers, surveyors, geometric thinkers. Their monuments are not accidents of labor. They are products of a mathematical tradition that predates written history, revealing a sophisticated intellectual world still waiting to be fully understood. As evidence from across the world accumulates, a new picture of ancient humanity comes into focus. It is a picture far more complex, interconnected, and advanced than the conventional timeline allows. Each discovery challenges a different pillar of the established narrative, but together they form a pattern too strong to ignore. The past was not a slow and simple journey from primitive groups to organized civilizations. Instead, it appears to have been marked by sudden leaps in knowledge, periods of innovation that seem out of place, and cultural traditions far older than written history. The 6 discoveries explored in this documentary are the clearest examples of this forgotten chapter. At the center stands Göbekli Tepe, the oldest known ceremonial complex in the world. Built 12,000 years ago, its T-shaped pillars, precision carvings, and astronomical layout break every rule of what Stone Age societies were supposed to be capable of. The discovery of 50 additional pillars in 2025 expanded the site from an archaeological curiosity to a monumental contradiction. It suggests that the earliest humans gathered in large, organized groups, coordinated engineering projects, and practiced symbolic traditions long before farming, writing, or permanent settlements. The site refuses to fit the timeline. Instead, it forces the timeline to expand around it. Close by, Karahantepe reveals a different aspect of prehistoric sophistication. The carved human face found there, along with the seated figures and chamber systems, demonstrates artistic realism and symbolic understanding that should not exist at 11,000 years ago. These carvings reflect identity, emotion, and structured social imagination. They show that early humans were not simply surviving the end of the Ice Age. They were creating meaning, culture, and possibly shared belief systems that connected multiple sites across the region. Thousands of miles away, deep beneath the jungle canopy, lies the lost Mayan city uncovered in 2025. Its size, planning, and integrated infrastructure pushed the origins of Mesoamerican civilization centuries earlier than thought. The presence of roads, reservoirs, and ceremonial structures demonstrates mature urban planning. This discovery questions the very idea that the Maya evolved slowly from small settlements. Instead,
It suggests the abrupt emergence of a large-scale society, hinting at earlier developments that have yet to be found. The band of holes in Peru adds yet another layer of complexity. 6,000 evenly carved pits stretching across a desert ridge indicate large-scale labor, organization, and possible economic administration in a landscape where no settlements exist. Traditional theories of storage or ritual fail to explain the sheer scale and precision. But the idea of a prehistoric trade distribution system offers a new perspective. If correct, it implies that early Andean societies were far more organized and economically
sophisticated than previously believed, managing goods, contributions, and accounting long before formal states appeared. On the far side of the world, the Boscombe site in Australia challenges assumptions about the technological abilities of early humans. At 40,000 years old, it shows advanced stone engineering methods, including heat treatment, controlled pressure flaking, and polished surfaces. These techniques require planning, training, and continuity. The site suggests that early Australian populations maintained networks of knowledge, passing down technical skill across generations, even in mobile societies. Their innovations are not late developments, but deep prehistoric achievements. Finally, the enigmatic writing and measurement systems found across various regions offer the most disruptive insight of all. Ancient scripts in Southeast Asia remain undeciphered but reveal early symbolic communication that predates formal writing. At the same time, standardized measurement units appear in structures built by cultures with no known contact across continents. The consistent ratios and geometric principles found in these structures indicate a global pattern in ancient mathematics. Early humans measured, aligned, and calculated with a precision that contradicts the belief that mathematics began only with urban civilizations. When viewed together, these discoveries challenge the core belief that human progress follows a linear path. Instead of slow and steady development, the past appears punctuated by moments of rapid advancement. Ideas emerged, spread, and sometimes disappeared, leaving behind only fragments in stone, soil, and forgotten cities. This pattern suggests that human history may have included periods of knowledge now lost to time. Rather than a single cradle of civilization, multiple regions may have generated their own bursts of innovation, shaping the world in ways only now becoming visible. The 6 discoveries form a map of ancient intelligence. They reveal architects, artists, astronomers, traders, engineers, and storytellers long before formal civilizations rose. They show that early humans built not only for survival, but for meaning, identity, and connection. Each site offers a piece of a larger puzzle. Göbekli Tepe points to early ceremonial organization. Karahantepe reveals symbolic realism. The Mayan city exposes hidden urban complexity. The band of holes highlights economic coordination. Boscombe reflects technological ingenuity. The lost scripts and measurement systems showcase forgotten knowledge. Together, they reveal a forgotten chapter of the human story, one in which ancient people were not passive wanderers. They were creators, observers, innovators. They shaped landscapes, aligned structures to the sky, recorded memory in symbols, and built with mathematical awareness long before history began. As the evidence accumulates, a realization begins to take shape. For every discovery that expands our understanding of the ancient world,
There are 10 questions rising behind it, waiting in the shadows. The more we uncover, the more we sense that our version of human history is incomplete. Not wrong, but unfinished. These discoveries do not simply add details to the timeline. They change the shape of the timeline itself. They expose how much we still do not know, how many stories remain buried beneath soil, stone, and vegetation, and how many breakthroughs vanished long before recorded memory. One of the most striking questions concerns how knowledge was preserved and transmitted. Sites like Göbekli Tepe and Karahantepe show symbolic mastery, yet no written language survives from their builders. How did their knowledge endure long enough to shape monumental architecture? Was it encoded in ritual, music, or repeated gatherings? Did teachers exist, passing down techniques across decades? If so, what training systems did these early cultures rely on? Without answers, we are forced to confront a deeper truth. Human intellect existed long before human writing. Another major question concerns the abrupt nature of ancient innovation. Many of the sites examined in this documentary appear without clear developmental stages. The lost Mayan city did not emerge slowly from smaller towns. It appeared as a fully formed urban landscape. The Band of Holes does not show early experimental versions. It presents a complete system. Boscombe does not reveal primitive tool-making. It shows refined craftsmanship. Why do these innovations appear suddenly? What triggered these bursts of creativity? Climate change, migration, cultural fusion, or something more complex? The pattern repeats across continents, suggesting a shared human tendency toward rapid leaps of complexity that archaeology has yet to explain. There is also the mystery of absence. Why did some of these traditions vanish? The writing systems of Southeast Asia faded long before they could influence later civilizations. The measurement units that shaped early monuments did not evolve into formal mathematical schools. The knowledge of heat-treating stone in Australia did not lead to metalworking traditions. These disappearances challenge the assumption that progress is always cumulative. They suggest that cultural knowledge is fragile, vulnerable to disruption by war, disaster, migration, or simple shifts in population. Entire intellectual frameworks can disappear within a single generation, leaving behind only faint traces. The role of environment raises another unanswered question. Many of the most complex ancient sites lie in places that are now harsh or isolated. The desert ridges of Peru, the highlands of Australia, the dense jungles of Guatemala, the rocky plateaus of Turkey. Did these environments shape early innovation? Or did the innovations appear before the environments changed? If climate shifts buried cities, erased traditions, or forced migrations, then the record we see today represents only a sliver of this time, what once existed. Perhaps the most provocative question is whether these ancient developments were isolated events or part of a larger pattern of human knowledge that once extended across the world. The similarities in early measurement, stone engineering, agricultural planning, and sky observations suggest that ancient humans often solved similar problems in similar ways. But the consistency sometimes feels too strong to ignore. Could there have been networks of cultural exchange older than the Silk Road, older than seafaring civilizations, older than the earliest known migrations? If such networks existed, their traces have not yet been found.
but the possibility forces us to reconsider how connected the ancient world might have been, even in eras long assumed to be isolated. Modern science also faces its own limitations. Archaeology depends on survival. Organic materials decay. Wood vanishes. Leather crumbles. Knowledge recorded in short-lived mediums does not survive the centuries. What remains are the few durable materials that can withstand time: stone, clay, bone, and architecture. Because of this, entire intellectual worlds may have existed in forms that nature did not preserve. We may be seeing only the shadows of ancient brilliance, not its full expression. Yet within these unanswered questions lies opportunity. New technologies like LiDAR, ground-penetrating radar, and microanalysis are revealing details unimaginable a generation ago. Entire cities once hidden beneath forests are now visible. Submerged landscapes lost to rising seas are being mapped. Microscopic wear on stone tools tells stories that ancient peoples never wrote down. Each discovery opens a window into a forgotten world, prompting us to ask better questions and search with sharper tools. The unanswered questions also invite us to reconsider our own assumptions about progress. If early humans were capable of sudden leaps of innovation, what does that say about human potential today? If knowledge could be preserved without writing, what forms of memory do we still rely on that future archaeologists will never see? If entire intellectual traditions could vanish, what ensures the survival of ours? As we reflect on the 6 discoveries presented in this documentary, a final theme emerges. These ancient societies were not incomplete versions of us. They were fully human, with curiosity, skill, imagination, and ambition. They looked at stone and imagined shape. They looked at the sky and imagined order. They looked at the earth and imagined how it could be reshaped. Their achievements remind us that human intelligence did not begin with modern civilization. It has always been part of who we are. The past still holds mysteries waiting to be uncovered. Somewhere beneath unexcavated mounds, within unexplored caves, or hidden beneath thick forest canopy, more chapters of this forgotten history are waiting. And as we continue to search, one question rises above all. Which unanswered mystery will reshape our understanding next?